Okay. So there are a lot of different methods for factoring. Yesterday was factoring using the distributive property. That's factoring by using the greatest common factor, the GCF. Today we are factoring by grouping. So the method is called grouping, and we'll see when we use that. And this is just a reminder, you had this definition on your note sheet yesterday as well, that factoring is expressing a polynomial as the product of monomials and polynomials, and product again means which operation? Yes, multiplication. So product means to multiply. So you are finding what multiplies together to equal what I'm given. Okay, it's the reverse of multiplying is what factoring is. Then, factoring by grouping, we use this method when a polynomial has 4 terms. So grouping is when your given polynomial has 4 terms. Terms, remember, are separated by addition and subtraction. I am going to show you this using the box method. Some of you used the box method when you did FOIL or when you did the multiplying. So this is using the box method in reverse. But I do think even if you didn't need to use the box method for multiplying, it's very helpful when factoring. So what we want to do, we're factoring 4QR plus 8R plus 3Q plus 6. And you can see we have 4 terms. So we're going to factor by grouping. You should, though, always check, like we did yesterday with factoring, always check first to see if all of your terms have a common factor. So if we look at 4, 8, 3, and 6, and then we'll look at variables next, but 4, 8, 3, and 6, is there a number besides 1 that you can divide all of those by? 4, 8, 3, and 6. What do we think? Can they all be divided by 2? No, because of the 3. We can't divide them all by 3, so I would say no. If it was just 4, 8, and 6, those are all divisible by 2. But always check for that first. If there is a GCF with all of the terms, you should factor that out as a first step. We will have examples like that. Then if there's no GCF, here is the box method. So you're going to make a 2 by 2 box, or think of it this way. It's a box where you're splitting it into 4 boxes like this. Okay, and then I'm going to put my 4 terms in the 4 pieces, but here's the order you should put them in. I guess just put them in order. So the first term, the 4QR, I'm going to put in the first box on the top. Then the positive 8R goes in the next box. Then I go to the bottom row, the positive 3Q goes in the next box, and the positive 6 in the last box. If any of those, if I had minus signs, that means they're negative. I should put the negative symbols in there with them, but they're all positive. And then what I do is I go across each row and down each column, and with each pair of terms, I factor out the GCF. I take out the greatest common factor. So for the first row, I'll do the rows first. 4QR and 8R, what do they have in common? They have a 2 in common. Greatest, they have a 4 in common. You can divide them both by 4, so you want to take out the greatest common factor. Do they have any variables in common? Nadia? They have an R in common, so I can take out a 4R. Okay, Then I do the same thing in the second row, 3Q and 6. What's their GCF? 3. I can divide them both by 3. They don't both have a variable, so that's just it, 3. Okay, now I do the same thing in each column, so I'm going to look at column 1, 4QR and 3Q. What do they have in common? They have a Q in common. Is there any number you can divide 4 and 3 both by? Besides 1, no. So you could just put Q. You can also have the 1 in front of the Q. The 1 doesn't have to be there, but you can put it there. And then what about 8R and 6? They have a 2 in common. And they don't both have a variable. So now here is how I get my answer. Here's the factored form. Because this 3 is positive here, there's like a plus sign in between. So one of my factors is the quantity in parentheses 4R plus 3. And then notice I just put another set of parentheses. There's multiplication in between, so you're not putting a plus or minus symbol in between. This is my second factor, my second set of parentheses. And again, this is positive, so I could put a plus there. I have 1Q or just Q plus 2. That is my factored form. Okay, but it requires taking out GCFs. And it is, like I said, it's the reverse of, well, actually, let me ask you this. If I wanted to check and see if this was right, what would I do? I could use another box method, but what am I doing? Casey? You're doing FOIL. Yes, you're multiplying. So you could check using FOIL. Because I said when you're factoring, you can always check. Factoring is also can be referred to as reverse foiling. So if I were to use FOIL, I'd have 4R times 1Q, so 4RQ, which RQ and QR, those are the same thing. I just wrote them in a different order. And then I have 4R times 2 would be plus 8R. Then I have 3 times 1Q, so plus 3Q. And then 3 times 2 is plus 6. And so I got what I started with. That's how I know I factored it correctly. Okay, reverse again. Reverse of what we did in the last chapter. Reverse of multiplying. Questions there? Okay, so let's look at number 2. We're factoring Rn plus 5n minus R minus 5. If it helps, for these terms that don't have a number, you can put the 1 in front, if that helps. So if I go, well, first look, is there anything that all 4 terms have in common besides a 1? No. Okay. So let's do the box. Okay, put your terms in. So I have 1Rn. Again, you don't have to have the 1 there. I wrote the 1 in, but you don't have to write that in front if you don't want to or don't need to. Then I have a positive 5n. Now, since I have minus 1r, I need to put negative 1r. The minus sign goes in there with it. And the minus 5 is a negative 5. Okay, and I go across my rows, down my columns. So in the first row, 1Rn and 5n, what do they have in common? They both have n's. And you could have n, or you could have the 1 in front of it. If the 1 in front of it helps you, put it there. Now in the second row, we have negative 1r and negative 5. What do they have in common? They both have negative signs. So what number would you be factoring out, Casey? A negative 1. Sometimes your GCF is just a 1 in this case, and that's okay. Now, the only reason I'm taking out the negative, though, say this one, the 1r was positive. If this was positive and this was negative, I would just take out a positive 1. So the only time you take out a negative is if the first one, either in a row or in a column, the first one in that row or column is negative, take the negative out with it. Okay, so we'll see that here. Now if I go down in the columns, 1rn and negative 1r, what do they have in common? They both have an r. The top one is positive, so even though this one's negative, I'm not taking out the negative. I just take out a positive 1r, or just r. And then 5n and negative 5. They both have 5. And again, the top one's positive, so I just take out a positive 5. Okay, that's it. So now, but you have to write your answer. Don't just leave this. Leaving this is not answering the question. The factored form, so I have this, which is in parentheses 1n minus 1, times this one here, and since that 5 is positive, there's a plus sign, so times 1r plus 5. Or you don't have to have the ones in front of the variable. So if you had n minus 1 times r plus 5, same thing. So either one of these answers, if you put the ones in front, if you didn't, they're both correct. Can you wait till we're done with notes so you don't miss anything? Okay. All right, questions there? Cassie?
So it says 1RN, but when you go to do the check, shouldn't it be NR instead of RN?
Yep, and NR, so the order that these are in when you multiply doesn't matter. So kind of like up here when I multiplied these, I put RQ and it was QR here. They are the same. Yep, but good question. I'm glad you're checking. Okay, let me see here. Let's actually, so I want to leave time for you to work. I'm going to skip over 3 right now. We have another example, but let's look at 4. So here we are factoring. Now this one, I do have a note here, but I had set this for the first 2 on the front. If there's a GCF for all 4 terms, you must factor that out first before you factor by grouping. So that's a hint to you that in number 4, there is a GCF. So 6mn minus 24m plus 9n minus 36. So anybody know, well, first of all, you can see not all 4 terms have a variable, so there's no variable in common. So what number can you divide 6, 24, 9, and 36 all by? You can divide them all by 3, yes. So there is a GCF of 3. I need to take that out first. So remember when you take the GCF out, the GCF goes in front, and then in parentheses you write what you have left when you divide these all by 3. So what is 6mn divided by 3? 2mn, and then minus 24m divided by 3 is 8m, plus 9n divided by 3, and then minus 36 divided by 3. (36 divided by 3). Casey? Yep, it should be minus 12 there. Okay, so GCF we took out first. Now, for what is in the parentheses here, this is still 4 terms. So now I factor by grouping here. I do the box method with these 4 terms, not the original 4, but these 4. So if I set up the box, so my first box should have 2mn, then a negative 8m, then a positive 3n, and then a negative 12. Okay, and I do the box method here. So go across the first row, 2mn, negative 8m. What would I take out? What's their GCF? They have an m. Anything else? They have a 2. Okay, first one is positive, so it stays positive 2m. In the second row, 3n and a negative 12. 3. Do I keep it positive 3 or change it to negative 3? Keep it positive. The first term in the row is positive. So it's 2m plus 3. Now down the columns. 2mn and 3n. They both have n. Again, you could have the 1 in front. Then negative 8m and negative 12. 4. It would be a negative 4 because the top one, the first one in the column, is negative. So that's n minus 4. So I have 2m plus 3 and n minus 4. So here's how you write your answer because you also had a GCF. The GCF of 3. GCF stays there. You need the 3 in front. Then I write my parentheses. So times in parentheses 2m plus 3 times in parentheses n minus 4. This is your full answer. That's fully factored. Yes. If you were to check this one, you'd have to do 2 different things. You'd want to FOIL first. Then after you FOIL, you would distribute the 3. So if you were to check something like this, FOIL first, then distribute the 3. So it's kind of like working backwards from here. Last question is, again, just a written response. 1 sentence is all you need, but it's making sure you understand what we're talking about. So it says, Martin and May, I need it quiet, please. Martin and May were asked to factor the binomial. They're factoring 10x squared plus 20x. This is Martin's factored answer, 5x times 2x plus 4. May's answer is 10x times x plus 2. And it says when they check their answer by multiplying using the distributive property, they both get 10x squared plus 20x. So here if I distribute, 5x times 2x is 10x squared. 5x times 4 is 20x. Okay, that works, right? Here if I distribute, 10x times x is also 10x squared. 10x times 2 is 20x. So they both, when they distribute, they get back to the correct answer. However, only one of them is fully right. It says who factored correctly, Martin or May, and then explain why and the mistake the other person made. So who is right? Nadia?
May, because she went with the GCF.
Okay, May is correct. GCF stands for greatest common factor. So 5 is a common factor, 10 is the greatest common factor. So we could say here May factored correctly. Because 10 is the, put an emphasis on greatest common factor of 10 and 20. And then I'm going to put a comma and say not 5. So that is Martin's mistake. He said 5 was the greatest common factor, and it's 10. They both had the X, which is right. So that's why it's important when you're looking at your sheet, you're choosing the greatest. Because some of you had that same question yesterday. Well, when I distribute, I get the right answer, but you need that greatest common factor.